We're going to talk briefly about something called the travel cost method. It's a way of measuring non-market values, consumer surplus around things that aren't widely traded in a market setting. We're going to see that it's most commonly applied to recreation. So if you have a recreational issue that starts to look at visitation, then this might be the non-market valuation method for you. So folks looking at open space and visitation, pay special attention. So the idea is that there's a demand curve and there's consumer surplus under that demand curve, right? We want to know the size of that. We want to know the value of in this case, a location. So I'm going to frame most of my discussion around things with location. This is going to be a key part of travel cost method because we're going to look at the cost people spend to get to a location. So get to a place, to do something. So if we think of the traditional demand curve, we can replace price on the y-axis with travel costs. So we still have quantity on the x-axis. Quantity now is the number of trips. The y-axis is the price to get there. So the idea is that things that cost more, we consume less of. This is the law of demand. And things that cost less, we consume more of. So if the price to get somewhere is lower, we should go there more often, all else equal. So if two sites are exactly the same in all other features, so in the things that we like about sites, then the one that is cheaper, the one that costs less to get there, should be visited more often. So if we look up, or if we sort of sort locations, and let's say one location, if we look at people, some people will live further away than others, and we would expect those people that live further away to go there less often because the price of getting there, the travel cost is higher. So if the site is free, so if there's, or even if there are fees, folks that have to travel farther, all else equal, should go there less often. So we can stack those up. We can look at the number of trips as a function of the cost to get there, either in gas, in time, whatever. And if we do this for enough, we can map out that demand curve. So if we have enough observations, then we can start to map out the demand curve. Now, depending on your state, there's different ways to do this. So, let's just say there's different ways to do this. So, one is just an intercept survey. So if you sit at a trailhead all day, random days across the year, and people show up, you just ask their zip code. If you know their zip code, then you can calculate how far they've traveled. This is especially true for big sites. So at Rocky Mountain National Park, you can ask zip codes and get an idea of where people came from. Now, if it's a local park, you probably need to know more. So what's their address, or just ask them kind of how far, how many miles did you travel to get here? You can do this just simply by surveying people at a trailhead or at the location that you're interested in. So and once you have that, there's a couple different methods to calculate this. There's something called zonal statistics, so you can calculate participation rates from a zone. So if you were to draw a map around the park and people visiting, you just need to know what zone they're coming from, and then you can calculate the cost from those zones. Or this individual method, you just ask people what their costs are, and you can sum across individuals. Both of those are completely valid ways of doing travel cost methods. So we can dig a little bit deeper into the zonal method. So let's imagine that we have 3 towns, okay, and they have various populations. So when you're using the zonal method, you're going to look at participation rates, right? So you're going to look at participation rates from each zone, or in this case, from each town. So we have 3 towns, town 1, town 2, town 3, and they have different populations. What we're looking for is the percentage of people from that town or from that zone that visit. So let's say that there's, in town 1, there's 100,000 people, and 15,000 visitors. So 15,000 people from town 1 visit this park or this destination on any given year. And let's say that it costs $12.50 to get there from town 1, right? So we know where the towns are. We can calculate those travel costs. Town 2, we're going to say has 750,000 people, so it's much larger than town 1. So just based on population, you would assume that that there should be more people visiting, all else equal, right? So this is why you use participation rates rather than just participation numbers. We want to adjust for that population, especially in the zonal part of it. So for that town with 750,000 people, we're going to assume that 75,000 people visit, and that the cost to get there is higher, so $25. So the cost to get to this destination from town 2 is higher. Town 3, we're going to assume, is even further, costs more to get there. There's 1 million people that live in town 3, and the visitation rate for town 3, or rather the number of visitors, is 50,000. So from this, we want to calculate the visitation rate. So how many people, what percentage essentially of folks from each town visit the destination. So we can calculate that. We see the visitation rate for town 1 is 0.15. For town 2, so 75,000 divided by 750,000 is 0.1 or 0.10. And for town 3, it's 0.05. And you can check to make sure this makes sense. We should have that the more expensive town or destination, right, or origin point should have lower visitation rates. So town 3 is more expensive, $37.50 to get to the destination. It has the lowest visitation rate, right? So we want to make sure that rates decline as travel costs go up. And then we just graph it. So we have the price. The price is the travel cost on the y-axis. We can graph that for each town, and now the quantity, the x-axis, is the visitation rate. Right. So this is our demand curve essentially. We've now taken the information from our survey, where are people coming from, and we've mapped out this demand curve. So we can get some various, I guess, definitions of value, but we can also use it to evaluate a couple different scenarios. So keep in mind what this curve looks like here, this travel cost relationship, and we can ask things like, what happens if we impose a fee on visitation? What if we raise either the current price, or if we just impose a fee on visitation? What do you expect? So let's pause here real quick. So what would you expect to happen? Well, let's take that town that has the $12.50 price of getting there. Okay. The $12.50 reflects sort of a zero entry fee, so I haven't drawn any entry fees on this graph. So we want to have the same visitation rates at that $12.50. So what we're going to do is, well, let's do it in the next slide. We're going to shift the demand curve down by that $3, right? So if there's a $3 fee imposed, actually the people that are paying $12.50 are going to look like the people that used to pay $9.50. Does that make sense? So if the travel cost is $9.50, the full cost of getting there, the travel cost plus the fee, the full price of getting there is $12.50. So the impact of raising a fee is to shift the demand curve down by the price of the fee. So you can see there what those visitation rates are. You can, for various fees, you can figure out how many people will come. So and then come from each place, because the price, that travel cost method, or the travel cost is still there. So you can say, if somebody is from this town that has this number of people and the travel cost is this much, how many people, what visitation rate do we expect to see? So in the $3 fee scenario, we can we can look and compare those folks that had the travel cost of $37.50, for example, so that town number 3, and we can look to see what their visitation rates we expect to be. So this has really good sort of power, I guess, for predicting visitation. So this is the strength of travel cost. It's by far the most widely used method for recreational destinations. It allows you to measure value as well as to evaluate the impacts of fee changes. So travel cost method, if you're doing recreation, if you're doing something with a location, with a site, it's probably the most relevant non-market valuation method for you.